From the definition, power electronics may be defined as application of solid-state electronics for control and conversion of electrical power. So this application of power semiconductor devices for control and conversion of electrical power. The entire power electronics subject concept can be analyzed with the help of this table. So for that, we need to consider type of input supply and type of load. So we have two types of input supply, that is AC supply and DC supply. Coming to load side, again we have two types, that is same AC type and DC type. Let us consider first one. So we have AC supply and our load demand is DC. So we need to convert this AC to DC. So best example for this conversion is our mobile charger. So in our household we'll get 230 volts AC supply, but our load demand is, or our mobile is required only 5 volts DC. So for that we need to convert this AC to DC. So we need to place one converter in between supply and load with, to meet this load demand. So that device or the converter we call as rectifier. So rectifier is a device which converts AC to DC. So here two actions will take place, that is conversion and control. So conversion is from AC to DC. Control is nothing but from 230 volts AC to 5 volts DC. So in rectifier we are controlling and conversion action will take place. Coming to second type, input supply is DC or load demand is also DC. So here no need of any conversion, source conversion, because the input and load both are in same type. So only control action will take place. So for that we require chopper or DC converter. So these DC converters are of three types, that is buck boost, buck boost. Coming to third type, we have AC supply and load demand is also AC, so no need of any conversion here, but control action is required. So for that we have AC voltage controller and cycloconverter. So based upon frequency, we have two converters here. So without changing frequency and with changing frequency. So if we want to control AC voltage without changing frequency, then we go for this AC voltage controller. So with changing frequency, we need to control this AC voltage, then we will go for cycloconverter. So the best applications for this AC to AC conversion type is AC drives. So control of any AC motors, whether it may be induction motor or synchronous motor. Coming to fourth type, that is DC to AC conversion. So here we need to take both conversion process and control process. So our input is DC, output is AC. So we need to place one converter in between for conversion and control. So we call it as inverter. So inverter is a device which converts DC to AC. So best example for this inverter is UPS, uninterruptible power supply. So from this table we will discuss, or we know what is rectifier, which converts AC to DC. We know what is chopper, which controls fixed DC to variable DC. Third one is AC voltage controller and cycloconverter, which controls AC to AC. Fourth one is inverter, which converts DC to AC. So coming to the syllabus, so coming to the subject concept, so every course has its own objective. The objective of this power electronics course are to make the students learn about basic power semiconductor switching devices and their principle of operation. So we need to learn about power semiconductor switching devices from diode to advanced thyristors. And second objective is the various power conversion methods, controlling and design of power converters. So variable power conversion methods are we have four types, that is rectifiers, inverters, DC-DC and AC to AC. So how we are controlling and design of the converter. Coming to third, application of power electronic converters for domestic, industrial, aerospace, commercial and utility systems. So we need to know about what are the application of this power electronics. And the equipment used for this conversion process, that is AC to AC or AC to DC and DC to variable DC and AC to variable AC. So what are the equipments we'll use in this conversion process we need to learn. So these are the four objectives of our power electronics course. Coming to syllabus, we have 5 units. So in first unit, power semiconductor devices. So we need to learn about only power semiconductor devices. So second is phase control converters. So we call it as a rectifiers. That is which converts AC to DC. So rectifiers is our second unit. So coming to third unit is our choppers. Choppers are regulators. So chopper is which convert or which controls fixed DC to variable DC. Coming to fourth unit, inverters. So inverter is a device which converts DC to AC. So coming to fifth unit, AC voltage controller, cycloconverter. So which controls fixed AC to variable AC. So AC voltage controller without changing frequency, cycloconverter with changing frequency. Let's see the basic table. So from here, first unit is about solid state electronics or power semiconductor devices going to learn in first unit. So second unit is our rectifier, third unit is our chopper, fourth unit is inverter, fifth unit is AC voltage controller, cycloconverter. So from this we can analyze our entire 5 units. So coming to first unit, that is power semiconductor devices. So here we need to know about power semiconductor devices, starting from power diodes to thyristor family. So in thyristor family, SCRs, react and GT. Similarly, we need to learn about transistor family. So that is a BJT, MOSFET and IGBT. And finally, SCR is our core concept in power electronics. So we need to learn about basic theory of operation of SCR, static dynamic characteristics, turn on and turn off methods, and SCR in series and parallel combinations, and rating of these SCRs, BJT and IGBT. Coming to second unit, phase control converters. So that is converting AC to DC. So input side we have AC. So AC type we have single phase and three phase. So single phase converters and three phase converters. So we need to analyze this converter part with the help of three types of loads, that is R load, RL load and RLE load. Similarly in case of three phase also we have R, RL and RLE loads. Coming to third unit, that is choppers and regulators. So chopper is nothing but fixed DC to variable DC. So here also we have buck boost, buck boost. Other terms we call it as a step down and step up choppers. Here also we need to analyze the choppers with the help of R, RL and RLE loads. So coming to regulators, regulator is nothing but the same operation in terms of ICs. So coming to fourth unit, inverters. So input is DC, output is AC. So AC means again we have two types, that is single phase and three phase. So we have single phase inverter and three phase inverter. Coming to fifth unit, so that is AC voltage controller and cycloconverter. So without changing frequency, we'll go for this AC voltage controller. With change in frequency, we'll go for the cycloconverter. In detail, we'll discuss each and every units in upcoming sessions. So after seeing the all 5 units in our course, we have course outcomes. After going through this course, the students acquire knowledge about basic operating principle of power semiconductor devices. So what are the power semiconductor devices and how they are operating is our first outcome. Coming to second outcome, the operation of power electronic converters with rectifiers, chokers, inverter, AC voltage converter, cyclo converter and their control. So we need to know about the operation of each and every conversion operation. And fifth thing, and third course outcome is practical application of these converters. That is in the revenue sources. So after finishing this course, you start doing your project work. Coming to textbooks, so we have two standard textbooks, that is Power Electronics by MD Singh and Power Electronics Circuits Design Applications by M.H. Rashid, Muhammad H. Rashid. So this Muhammad H. Rashid is somewhat easy to understand. So MD Singh is also good, but for understanding purpose, M.H. Rashid is good as per my knowledge. So similarly, we have reference books, that is Power Electronics by Chiku Abraham and Power Electronics by P.S. Bindra and Power Electronics by E.R. Murthy. So these are the reference book. So better to follow this M.H. Rashid. So thank you for watching. Okay. Up to now we discussed about power electronics. So what we have as per JNJ syllabus. So as per JNJ syllabus, what we have in our 5 minutes we already discussed just now. So as per gate point of view, as per gate point of view, what are the important concepts in our power electronics subject we need to discuss now. So later we will do each and every topic. So coming to first unit, that is power semiconductor devices. So if we have a gate question on power electronics, so definitely they will touch SCR. So before going to the SCR, so we need to know what is diode, what is SCR, what is transistor family. So, so first we need to know what is diode. So as we know, diode is a two-terminal device consisting of only an anode and cathode. So for this diode, if you connect one source, consider we are connecting one AC voltage source. Let us have one load is of type R load. This is my supply V. So supply Vs equal to Vm sin omega t. So based upon this formula, we may get 2 or 3 bits if they want to ask on diode. So first we need to see what is a diode. So here we are giving input voltage, that is Vs equal to Vm sin omega t, that is sinusoidal waveform. This is 0, this is Vm, this is pi, this is 2 pi. So for this input, how my diode is acting? So during positive cycle, this is phase, this is neutral. So phase is connected to anode. So it is in forward conduction state. The switch is in on position. The switch is in on position. Will get same as input voltage. So during A2 of cycle, after reaching the pi interval, that is 0 to pi, we have positive supply. So P is positive,
and N is negative here. So the negative of that is pi to 2 pi. So this becomes neutral, this becomes phase. So at this point neutral is connected to anode, so it is in open state, that is off state. If my switch is in off position, there is no way to flow the current between source to load. Okay, so we'll get 0 volt. After from 2 pi to 3 pi, again we are entering into the positive phase. This is neutral, so phase is connected to anode, so it is in conduction state. So this is the diode, but or actually what we have in syllabus is SCR. So we need to focus much on silicon control rectifier. So when you are entering the silicon control rectifier, so if you observe clearly, so here whatever the input voltage we have, the same voltage we are getting at the output side. So this is V0. So what is the voltage we have? The same voltage we are getting. So the negative of it we are getting 0. Okay. But here we are converting. This is AC input. This is DC out. The rectification operation we are achieving. That is the process of converting AC to DC is nothing but a rectifier. So what we are going to study in our second unit. That is the phase control rectifier is nothing but rectifier. So here we need to convert AC to DC. So in order to achieve this operation, place one diode will get. But what is the drawback here? So we are not getting any control output voltage. What is the input voltage? We have the same voltage we are getting. That's exactly half of the voltage we are getting. So in order to make control output voltage. So here what is the V naught value? V naught equal to integration of 0 to pi Vm sin omega t. So what is the voltage we have? The same voltage we are getting. This is from 0 to pi. That's 0 instant it is starting. So we are considering at 0 to pi. But we need to get variable output voltage. We are converting AC to DC. The control action we are taking, but there is no AC to DC conversion action is taking place, but there is no control action. So in order to get the control action, we are remodifying this diode as SCR. So if you see the cross-sectional view of diode, so diode is a PN junction device. This is anode, this is cathode. So here we have only one junction J1. Whenever you positive to the anode, this junction J1 is forward bias condition. So this becomes forward bias condition. We are getting output voltage same as the input voltage. But here, what is our aim? To get the control. So not to get the control, I am adding one more terminal, that is gate terminal. So this modification we can call it as a SCR, silicon control rectifier. The same operation what we are getting the diode, the same operation we are getting, but the on instant at what instant it should turn on. So we need to decide. That is considered this is alpha. So we are getting the variable output voltage by keeping alpha. So I can keep alpha as 0, 5, 10, 15, 30 degrees, 60 degrees, 90 degrees. So up to we can go for 180 degrees also. If we give 180, we'll get straight line. 180 or 0. Okay. So up to 150, 160 also we can vary. So correspondingly we'll get the output voltage. Okay. So in order to get the control output voltage, we are going to add one terminal, that is gate terminal. So by doing some modifications in the SCR. So the modifications, we connect two diodes in series. It's nothing but SCR. PN, PN. So this is anode, this is cathode. Now, why? Because we added one more diode. So observe the junctions. Here we have J1, here we have J2, here we have J3. So we have three junctions. So P to N is forward bias condition. If you give positive supply to the anode, P to N is forward bias condition. So junction J1 is forward bias condition. Here, observe the J3. This also P to N. Junction J3 is also forward bias condition, but junction J2 is N to P. So it is not in forward bias condition. So what is our aim? Going to get the control output voltage. Not to get this control output voltage, I am adding one terminal, that is gate terminal. So this gate terminal, I need to give one pulse. This may be alpha. So this alpha may vary from 0 to 180 degrees. So if I give alpha value as 30 degrees, so at 30 degrees point, that is, let us say this is 30 degrees, at 30 degrees point itself, the junction J to become forward bias condition. Means I am using some external force to break this limitation. That is, there is no way to flow the current from N type to P type. So P to N, the current will flow. N to P, it won't flow. So in order to make the, we need to collapse this break or bridge or wall. I'm using one gate terminal. So in this gate terminal, I am giving one current or gate pulse. So whenever I am giving gate pulse at alpha, that is 30 degrees, 60 degrees, 90 degrees, whatever it may be, at that value, the junction J2 becomes forward bias condition. Okay, that's why I'm getting the control output voltage here. So this gate terminal will decide when should we get the output voltage. If you get the firing angle alpha, so we'll get the variable output voltage. So see here, for example, if I am giving 90 degrees, so alpha is 90 means, so up to 0 to pi by 2, pi by 2, alpha equal to pi by 2. So up to 0 to pi by 2, I am getting zero output voltage. Why? Because even the junction J1, J3 forward bias condition, J2 is reverse bias condition. So whenever I am giving triggering pulse at alpha equal to pi by 2, which makes junction J2 forward bias condition, which allows the current to flow from N type to P type, that is anode to cathode. So here we have gate type. Okay. So correspondingly, if alpha values vary, we get the output voltage, variable output voltage. So this is a basic difference between diode and SCR. So diode is an uncontrolled device, SCR is a controlled device. So in order to get the control, we are adding one terminal gate terminal. So in order to add this gate terminal, I am using two diodes in series. So here we have three junctions, J1, J2, J3. J1, J3 are always positive. If you give positive supply to anode, J2 is reverse bias condition. So in order to make J2 to forward bias condition, we need to provide some gate current. Okay. So that gate current will flow the current from at the corresponding angle of alpha. So we get the output voltage at desired output voltage. So by using the formula V naught equal to alpha to pi Vm sin omega t, we can calculate the output voltage. This is for in case of R load. So if we have RL load, that too if you want to control both positive off and negative off, that is a full wave rectifier. So in order to make it full wave rectifier, so we will arrange the circuit in such a way that the source, one more figure, in order to control both positive off and negative off, my source will be the same, my load will be the same, R load. So here I need to connect both positive off and negative off into positive. For time being, I am analyzing first with diode. Consider this is T1, T2, T3, T4. This is my input supply, same what we given is equal to Pm sin omega t. So now our aim is to convert both positive off and negative off into positive. So during positive off cycle, that is 0 to pi, 0 to pi. So this is phase, this is neutral. The space is connected to T1 anode, neutral is connected to T3 anode. So T3 is reverse bias condition. We have only one direction, that is current will go from phase to T1 to my load to. If I turn on the T4, it becomes short circuit. So there is only one possible way, that is T2 to neutral point. Current will separate in this loop. The same, if you use diode, we get the same output voltage what we have in input side. If you connect diodes, sorry, if you replace diodes with SCR, we'll get the control output voltage. And so alpha I'm giving. So at alpha only we're getting the output voltage. So up to here is the same operation during A2 off cycle. During A2 off cycle, this become neutral, this become phase. So now observe, so this is phase. So phase is connected to T3 anode. So it is in forward bias condition. So current will flow from T3 to load to. So if turn on T2, it becomes short circuit. So I'm entering into the T4 to neutral point. So current is circulating in this loop. So if you observe here, both T1 is entering in the same direction, T3 also, and there is negative off cycle also enter the same direction. So we are converting negative off into positive off. This is for series for diode. So place S here, we'll get the output voltage. So this red line is the output voltage with respect to SCR. So if you place SCR, we can control both positive off and negative off. So based upon our desired firing angle alpha. Okay. So here, if we have R load, this is the output voltage. If we have RL load, if we have some inductance, it won't turn off at 5. So it takes some time. So we get some negative spike. So this negative spike is due to the inductance. So based upon inductance value, if you have small amount of inductance, this may be a negative spike. If you increase the inductance value, it may come up to the next cycle. So this negative spike depends upon the what is the value or what is the amount of inductance current in the load. So this is about R load and RL load. So if you want to control both positive off and negative off, so we need to go for full bridge. So in full bridge, either we can use all 4 are resistors, so we can call this a fully controlled converter. So it means fully controlled means, so you may get question in power gate exam. So how many resistors required in fully controlled full bridge inverter? Similarly, fully controlled semi-controlled, so full bridge semi-controlled converter. So semi-converter means 2 resistors and 2 diodes. If you replace diodes with resistors with diode also, we'll get the same operation. But because initially we are controlling with the help of upper group direction. T1 and T3, with the help of T1 and T3, we can control. So if we control with the help of these, so we can call it a semi-control. If we control all, if we use all the control switches, then we call it a fully control. Clear? So you may get question. So what is the V0 value for this? Answer: only positive of cycle. That is integration of alpha to. So alpha is the starting instant. So here we have one extension angle, that is beta, represented with beta. V naught equal to integration of alpha to beta Vm sin omega. So these are the basic formulas I am giving. So based upon these formulas, you may get questions. So if you know the V naught value by using this equation, alpha, beta. So in question they may give firing angle alpha, extension angle beta value. So Vm value they will give. So just we need to find out the V naught value and we need to find out the I naught. So as remember, I naught equal to V naught by R. So as we are getting the DC output voltage, power equal to V into I. In case of DC, if you are talking about AC, we are going to add cos phi also. But here we are talking about DC, we are converting AC to DC. Simply we can add P equal to VS. So in this case, if we give firing angle alpha equal to 0, we'll get the output voltage max. If alpha equal to 180 degrees, we'll get V naught equal to 0. There is no value. There is no time period where the switch is get on. So we'll get completely 0. We'll get 0. So in order to get this 0 output voltage, we need to give firing angle alpha equal to 180 degrees. So if you want to get the maximum possible output voltage from the input source, then we need to give firing angle alpha equal to 0. Clear? So this is about basic difference between diode and SCR. So similarly, in upcoming classes, we will discuss about, so here in first unit is completely about switches, so SCR, MOSFET and IGBT. So turn on process and how we are getting this SCR two transistor analogy. So based upon this, we may get questions. So initially we have one diode. So this diode is uncontrolled device. So in order to make the control output voltage, we are entering the transistor family. So in transistor family, we have BJT, MOSFET, IGBT. So all these switches require continuous gate pulse. So it's a drawback in this. So not to overcome this, we are going for this SCR. So SCR required only at the starting instant itself. We need to give the triggering pulse. That is just going to make junction J2 forward bias condition. Okay. So next section is about rectifiers. So just to convert AC to DC. So third is about choppers. So choppers are very important. Fixed DC to variable DC. So next class we'll discuss about choppers and we'll solve some problems on this. Next fourth unit about inverters. So inverter is nothing but to convert DC to AC. So here DC to AC means we are entering into the frequency term. Means going to maintain, this is my input. If you use normal inverter, we'll get square waveform. But AC means what up to now we discussed about. AC means pure sinusoidal waveform. So in order to apply this pure sinusoidal waveform, we are going for three phase, that is 120 degree conduction, 180 degree conduction. Okay. So here we have basic series inverter, basic parallel inverter. So based upon commutating element. So you may get questions from what is the difference between how commutating elements are connected in series inverter. The commutating elements L and C are connected in series. So we can call it as a series inverter. Similarly, if you connect commutating elements L and C are in parallel, then we call it a parallel inverter. Okay. If you about AC voltage controller, so fixed AC to variable AC without changing frequency, you can call it as a AC voltage controller. So cycloconverter means fixed AC to variable AC with changing frequency. Okay. So this is the basic overview of all 5 minutes. So just today class we discuss about what is difference between diode and SCR. So how the questions may arise. So questions may arise based upon concept. So V naught, I naught, and P. So either they miss any one term, alpha or beta or Vm or V naught. So they may miss any one term and we need to find out. We may get questions from when we'll get the maximum output voltage and we'll get the minimum output voltage. And what is the question may arise from SCR basic P junctions, how many junctions we have. So basic PG questions we may get or numerical problem based upon this formula. Okay. So next class we'll discuss about choppers. So choppers are very important concept. So in choppers we have step up, step down, step up. So in general we can call it as a buck, boost. Second one is boost, Buck means going to reduce the output voltage. Boost means going to increase the output voltage. Sometimes we require both step down or step up. So at the time we'll go for VB converter, buck boost converter. So next class we'll discuss about this converter and we'll solve some numerical problems in terms of gate finder. Thank you. Clear? So this is about basic difference between diode and SCR. So similarly, in upcoming classes, we will discuss about so here in first unit is completely about switches, so SCR, MOSFET, and IGBT. So turn on process and how we are getting this SCR two transistor analogy. So based upon this, we may get questions. So initially we have one diode. So this diode is uncontrolled device. So in order to make the control output voltage, we are entering the transistor family. So in transistor family, we have BJT, MOSFET, IGBT. So all these switches require continuous gate pulse. So it's a drawback in this. So not to overcome this, we are going for this SCR. So SCR required only at the starting instant itself. We need to give the triggering pulse. That is just going to make junction J to forward bias condition. Okay. So next section is about rectifiers. So just to convert AC to DC. So third is about choppers. So choppers are very, very important. Fixed DC to variable DC. So next class we'll discuss about choppers and we'll solve some problems on this. Next fourth unit about inverters. So inverter is nothing but to convert DC to AC. So here DC to AC means we are entering into the frequency term. Means going to maintain this is my input. If you use normal inverter, we'll get square waveform. But AC means what up to now we discussed about AC means pure sinusoidal waveform. So in order to apply this pure sinusoidal waveform, we're going for three phase, that is 120 degree conduction, 180 degree conduction. Okay. So here we have a basic series inverter, basic parallel inverter. So based upon commutating element. So you may get questions from what is the difference between how commutating elements are connected in series inverter. The commutating elements L and C are connected in series. So we can call it as a series inverter. Similarly, if you connect commutating elements L and C are in parallel, then we call it a parallel inverter. If you about AC voltage controller, so fixed AC to variable AC without changing frequency, you can call it as a AC voltage controller. So cycloconverter means fixed AC to variable AC with changing frequency. Okay. So this is the basic overview of all 5 minutes. So just today class we discuss about what is difference between diode and SCR. So how the questions may arise. So questions may arise based upon concept. So V naught, I naught, and P. So either they miss any one term, alpha or beta or Vm or V naught. So they may miss any one term and we need to find out. We may get questions from when we'll get the maximum output voltage and we'll get the minimum output voltage. And what is the question may arise from SCR basic P junctions, how many junctions we have. So basic PE questions we may get or numerical problem based upon this formula. Okay. So next class we'll discuss about choppers. So choppers are very important concept. So in choppers we have step up, step down, step up. So in general we can call it as a buck, boost. Second one is boost. Buck means going to reduce the output voltage. Boost means going to increase the output voltage. Sometimes we require both the step down or step up. So at the time we'll go for VB converter, buck boost converter. So next class we'll discuss about this converter and we'll solve some numerical problems in terms of gate pointer.